So we're going to look now more in depth at how we present the results, and then also talk more about what it means to do this adjusting and give some examples. So this is a very interesting paper from the UK, looking at the relationship between obesity and happiness, and they're also looking to see if there's an effect of their health. So it's a cross-sectional study, so we can't talk about cause and effect, we can only talk about associations or relationships. And the main outcome in this case is self-reported happiness. Now they did ask them this question on a 5-point scale, so they could have answered extremely, very, or moderately, but they grouped all of them together as being happy, oh my poor arm, and then the moderately, very, and extremely would be grouped together as unhappy. So I'm assuming that moderately is a different level for the happy and unhappy. So 6-point scale probably rather than 5-point scale. So our primary outcome is happy or unhappy, which is binary. So what they say as the results of the paper, and this is just taken straight from the abstract, is that overall that there is a very low prevalence of unhappiness, 4.6%, but for every one normal weight participant who was unhappy, 1.33 class 3 obese participants were unhappy. So they're discussing whether or not there is a link between unhappiness and obesity. Then there's another big but, that after they adjust for health, there is little association between obesity and unhappiness. So what they're saying is, although it might look like there's a relationship between being obese and being unhappy, actually if you take account of health, and some obese people might have poorer health, it could be that poor health which is causing the unhappiness, not the obesity. So let's have a look at how they've reported some of these results in their results table. As you can see, this is a great big table. I'll get out of the way. What they've done is they've given the overall results, then they've given the results just for the men, and then the results just for the women. In each case, they've given the univariate, which are the crude or the unadjusted odds ratios, and then they've also given the multivariate results where they have adjusted for everything they've listed at the bottom. So age, sex, SES, employment, ethnicity, alcohol, smoking, comorbidities, and they've given a nice little list there of what they've used. So we're not going to look at the whole table because there's so much information jam-packed in there. We're just going to look at the very first part of the table and take an in-depth look at what happens between the crude or the univariate odds ratios and what can happen when we then adjust for other variables. And I'm just looking at the overall analysis, not the one separated by men and women, but you're welcome to look up the paper and have more of an in-depth look. So the outcome is binary because it's happy or unhappy, but we actually have, 6 categories for BMI: underweight, normal, overweight, and then the class 1, 2, or 3. So if we have a little look at the odds ratios for the univariate case, so that's to the side there. Oh, I can't stay on the side, I can only look forward. I'll get out of the way. I thought I might be able to look towards the left or right to show you where I was. Oh, hold on, I can probably point that hand actually. Pointing on that side, good. So the reference category is normal weight. So if you remember with odds ratios, we're always comparing with something. We're not just saying outright what's the prediction that you're unhappy. So it's all compared with our reference category of normal weight. So compared with normal weight people, are underweight people more or less likely to be unhappy? And they say up the top there, I've cut out part of that when I was cropping it down, but they're reporting the odds of being unhappy. And it looks like the underweight people are more likely to be unhappy. The overweight people, we have an odds ratio here less than 1, so they're less likely to be unhappy. And then for the last 3 categories, they're more likely to be unhappy. So let's have a look at what that might be in a graph, because sometimes it can be a little bit easier to see as a picture. I wonder if I've just walked to the wrong side. See which way the graph comes up. Yep, the wrong side. Okay. So sometimes what you get instead of a table is you get a nice picture showing you what you're looking at. And in this case, we're comparing everything with an odds ratio of 1. And the healthy weight people don't have a confidence interval because they're the reference category. If the confidence interval doesn't touch 1, then the results will be significant. So, and if you look at the p-values, you'll see they'll be less than 0.05. So what we can see here is that the underweight people are much more likely to be unhappy, as are the obese participants, but not the overweight participants. They're less likely to be unhappy. And this is just looking at these two variables, weight and unhappiness. It's not adjusting for anything else. In the next column of the table, they looked at the multivariate or the adjusted analysis, where they were adjusting for age, sex, socioeconomic status, employment, ethnicity, alcohol, smoking, and comorbidities. And here we can see that the odds of being unhappy have actually changed a little bit. So once you take into account all those other things, it doesn't look like obesity is actually changing your odds of being unhappy. If we take a look at these odds ratios here, and I'll pull out the pointer, these confidence intervals are crossing 1, so statistically there's no difference there from the healthy weight people. Again, the overweight people look like they're less likely to be unhappy, but there is still an effect for the class 3 obese and for the underweight. So that's adjusting for just those variables that they've listed up the top. The last thing that they do is that they then also adjust for self-reported health. Frustratingly, and I don't blame the authors, this could be down to restrictions by the publisher because there's so much in the paper. This is a supplementary table, so even though it's one of their main conclusions, you won't find it in the main paper. To see these odds ratios adjusted also for self-reported health, you need to go to the supplementary information. And in here, all the odds ratios have actually dropped again, and they've actually gone below 1, meaning they're more likely to be, they're less likely to be unhappy and more likely to be happy. So let me show you the picture for that. So now these odds ratios have all fallen below 1, except for the underweight people, although that interval is now crossing 1, so statistically no different from the healthy weight people. And they are all less likely to be unhappy than the healthy weight people. And this is after adjusting for all those other variables plus their self-reported health. So adjusting for these extra variables can have quite an impact on the results, so it can be really important to do this in your analysis. If we look at all three of them together, you can see what effect they're having. So the blue line is the univariate analysis, where they're not making any adjustments. The orange line is where they have adjusted for the first set of variables, and then the green line is where they've also adjusted for self-reported health. So it looks like, and this is what they say in the paper, that once you adjust for all these things, there's actually no relationship between your weight and your odds of being unhappy. And if anything, these people are actually less likely to be unhappy, and they don't talk about that in the paper, so I don't know how to interpret that, and I don't have the expertise to interpret that, but statistically they're less likely to be unhappy once you've adjusted for all these other variables. Now often what you'll see in a paper is not a graph going that way across. If they have given you a graph with odds ratios, and I do like it when papers do that because it makes it nice and easy to read, because you know you're comparing with the one and you're looking, are you more likely or less likely to have the outcome. Usually it'll be a vertical graph, which is just a little bit more fiddly in Excel to make it do it for you. But this is the same as the previous graph. I've essentially just twisted everything 90 degrees. So the univariate, adjusted 1 and adjusted 2. So I would encourage you to go back and read the whole paper, and they talk about what's already known on the subject and what this study is adding. I'll just walk out the way in case you want to pause and quickly read through that now. And then I'll just finish up by some things about logistic regression, some good things about it. And it almost never gets called anything else. So if someone's done a logistic regression, the chances are they've called it that, and you don't have to wonder if it's getting called another name. It's nearly always reported in terms of odds ratios with 95% confidence intervals. So once you get the hang of interpreting those tables or graphs, it should be fairly straightforward. You do often get a handy picture to help you interpret, and if you don't get one, then you can actually sketch it out yourself on a bit of paper based on their information. So you should be able to interpret the results of a logistic regression, even quite a complicated one, even if you don't know all the details of what they've done. So for this course, I would expect you to know how to run and interpret a chi-square test. I would expect you to know how to interpret the results from logistic regression when you read it in a paper. You can try using logistic regression in your project, but it's not required. If you want to try it, then I'll help you in the workshops. And you might have noticed that I didn't really cover any of the assumptions of logistic regression. Regression as a whole is just such a massive topic, and to really cover performing it well or doing it well, it would take a whole course. So we've just tried to touch on all the important points here for interpreting it when you read it in papers. And so the following videos, I'll just look at some more examples at reading it in papers and also running it in SPSS.